Hey guys, just as a reminder, we are starting a new unit called functions, and so we're going to start off with straight lines. So now recall from last class where I showed you guys this diagram where we see two people trying to walk a hill towards a beach. And so I asked you guys, how would you describe the difference between line A, B, C, D, E, F, G, and H? And so a lot of you guys took a good guess and actually gave me a lot of good answers, such as rise over run, the steepness, and such. And so in the end, you guys told me that you would use slopes as a way to describe the differences between each line. Now, before we dive in more into the first part of the functions unit, something that I do want to emphasize is that IEP does not use the word slope. They actually use gradient instead. And so just remember that whenever I mention gradient, that's the same thing as slope. So we're going to talk about the slope intercept form, now known as the gradient intercept form of a line. And so you guys already may know this as y is equal to mx plus b. So that equation did not go away. So hopefully from your previous algebra classes, you guys also went over how to find the slope between 2 points. So now we're going to call it the gradient of the line through points A and B. And so the formula is m is equal to y2 minus y1 all over x2 minus x1, where y2 minus y1 is the vertical distance, and x2 minus x1 is the horizontal distance. And so something that I do want you guys to take note of is that this is the same thing as being as visually seen it as rise over run, right? And so the rise is going to be, again, the vertical distance, so that's vertical, and then the run is the horizontal distance. So in case you forget, remember, you guys for sure remember rise over run. So the equation is going to be given to you guys, by the way. So it is one of those few formulas in the formula sheet that you guys will be given. So you don't need to memorize it, but you do need to know how to use it to find the gradient of a line. So now let's go ahead and go through the gradients and how their direction affects the sign that's going to be in front of the gradient. Let's go ahead and talk about a gradient that is positive. So when the gradient m of a line is positive, the line is increasing in the positive direction. And so something that a teacher from my middle school taught me, in case you guys are having trouble visually seeing it, is imagine a stick figure walking on the line, right? So if I draw a stick figure and it's going to walk on a line towards the right side, right? We see that it's actually going to go up, so it's going upstairs, so therefore it's increasing. So that means that the direction is positive, and that means that your slope is greater than 0. So all the values, or your gradient is going to be positive, is what I'm trying to say. Now for the negative gradient, so a gradient that is negative, if I were to draw a stick figure, and again, it's walking the line on the right side, so that means that it's going down, right? And so since it's going down, it's decreasing, so that means that the value of the gradient is going to be negative, as shown here, that the gradient m is less than 0. Now, if you have a horizontal line, so again, if you have a horizontal line, that means that your gradient is going to equal to 0. So if your gradient is equal to 0, something that I want you guys to look at is that remember that y is equal to mx plus b, right? So then that means that y is equal to 0 times x plus b. We know that 0 times anything is 0, right? So we have y is equal to 0 plus b. Another fact that we know is that 0 plus any value is going to be that value it's adding to, right? So 0 plus b is just going to be b. So y is equal to b. So remember that horizontal lines are basically y equals to its y-intercept. My bad, guys. So yeah, So always remember that horizontal lines, the equation of it is y is equal to its y-intercept. Now the last one that we're going to see is a vertical line. So if we draw our stick figure again, let me go ahead and switch back to green. Ooh, let's not use a highlighter. There you go. Okay. So if we switch back to our stick figure, we see that our little stick figure can't walk up or down or straight through the line, because we see that the line looks like a wall, right? And we know that we can't walk on walls, so therefore our slope is undefined. Now another thing that I want you guys to take note of is that let's say for example that this point, I go ahead and assign it as what would be a good variable, guys? Let's go ahead and assign it as d. So d comma 0. So we know that the x-intercept here is d comma 0, right? Because y is going to be 0, and the d value is wherever that point is at in the x-axis, right? So in general, when describing vertical lines as an equation form, it's going to be dx is equal to d. So again, horizontal lines is y is equal to its y-intercept, and then the vertical line is going to be x is equal to its x-intercept. So go ahead and note that difference, and we're gonna practice more in the future how to find those equations more easily. Alright guys, so a couple of things that I do want to mention is that starting this semester, I'm going to go ahead and centralize everything that I want you guys to do into Go Formative. So for example, the attendance question, guys, they're always going to be in the Go Formative assignment of the day or week. And so I'll make sure to go ahead and add the dates if necessary if I'm putting 2 attendance questions in one Go Formative assignment. Otherwise, it's just going to be the very first question on top that's going to be just random questions that I want you guys to answer. And then another thing that I want you guys to take note of for this assignment only is I want you guys to go ahead and fill out the question number 3, which is which level would you like to be in for semester 2. So if you guys were already opting in for IB or for on level, go ahead and just pick that answer choice again. If you guys want to switch, right now is the chance for you to switch, so that way I can go ahead and start differentiating the assignments for whatever you decide to pick. All right, so let's go ahead and start with number 4. So number 4 says determine whether the following point lies on the line, right? And so we have the equation y is equal to 5x minus 2, right? So, and then we're also given the points 3 and 13. So let me go ahead and highlight that point. So the point that we're given is 3 and 13. This is question part A, so I did divide the questions into parts, so that way that way we can put in our answers individually. But anyways, so we have the line y is equal to 5x minus 2, and we're given the points 3 and 13, right? So how do we figure out whether that point lies on the line? Well, something to take note of, guys, is that we know that our coordinates are in Cartesian coordinate form, right? So all that means is that it's a fancy way of saying that our first value is x and our second value is y, right? So that means that 3 is going to be our x and then 13 is going to be our y. Then, of course, we're given the equation y is equal to be 5x minus 2, right? So as the definition of functions that I'm going to later on emphasize is that x is going to be your input and y is going to be your output, right? So that means that 13 is going to equal to, or should equal to, 5 times, and then the x is 3, so times 3 minus 2, right? So that means that the left side needs to equal to the right side in order for that point to be on the line. And so when you do the math, and then let's go ahead and just go do the math, actually. So 13 is equal to, and we know that 5 times 3 is 15, so we have 15 minus 2. And then 15 minus 2, what does that give us, guys? Well, if you said 13, you're correct. Okay, so notice that our left-hand side equals to our right-hand side. So 13 is equal to 13. This is a true statement. Therefore, that means that our point does lie on the line. So when you guys write your answers in, I know that I told you guys different things, but just for the purpose of being consistent, when you write down your answers, you'll say, yes, the point 313 does lie on the line. Y is equal to 5x minus 2. So the whole sentence basically means that yes, the point that we're given does lie on the line, on the given line as well. Now using that same logic, guys, for number 5, it's going to be the same thing. Remember that 5 is going to be our x because we're following the Cartesian coordinates. So 5 is going to be our x, and then 3 is going to be our y, right? So when I rewrite my equation, so we have 5x minus 2 is equal to y, right? I'm going to go ahead and put it where it's y is equal to, so that way we're not confused. So y is equal to 5x minus 2, so it's the same line. And we're trying to determine if 5, 3 is on the line. So let's go ahead and plug it in. So again, remember that x is going to be our input and y is going to be our output. And so in this case, that means that y is our output. So that means that 3 is going to equal to be 5 times, and then what is my x? My x is 5. My x is 5. So replace x with 5. And I want to emphasize that it's replace, guys. So don't put x in there. So we're replacing x with 5, and then we're going to subtract 2. Okay? So again, all I did is I replaced y with our output, which is 3. And then I replaced, well, now it's going to be equal 5 times, and then the x got replaced with our input, which is 5, and then minus 2. So now all we got to do is do the math. So 3 is equal to b, and then 5 times 5 is 25. So 25 minus 2. So that means that 3 is equal to b. So what is 25 minus 2? 25 minus 2 should be 23. And let me go back to the pen here. So it's going to be 23. Okay. And then would you say that 3 is equal to 23? Would that be a true statement? Well, I hope that you say no. So 3 equaling to 23 is not a true statement. So in order for this to be a true statement, I'll have to cross out the equal sign. So that means that 3 does not equal to 23. So since the left side and the right side do not equal, what that means is that the point that we're given here, this point, does not lie on the line. So you'll write no. The point 5 and 3 does not, so make sure that it does not lie on the line. Y is equal to 5x minus 2. And so if you guys need a visual representation, if I were to draw out the line. All right, so let me go ahead and draw the line. So we have minus 2. Remember that your y-intercept is negative 2, so we're going to go down 2. So our y-intercept is here. And then our slope is 5. Since our slope is 5, which is basically 5 over 1, remember that's rise over run, right, guys? So we're rising up 5. So 1, 2, 3, 4, 5, and go over 1. So that will be our point, our line here. And so let me see if there's any tools here that I can use as a line. It probably doesn't, which is fine. I can go ahead and try my best to draw the straightest line that I can give y'all. And that is not a line. So let me go ahead and go back on the pen. There we go. So that's our line, right? And so we're also given the point 5, 3, right? So 5, 3 will be 5 over x. So 1, 2, 3, 4, 5, and then 3 up, right? 1, 2, 3. So our point will be here, 5, comma 3. And then see how the line does not lie. The point does not lie on the line. So this is how you can also visually represent your findings. So if you guys are more comfortable drawing the graph, just an advice to make sure that you guys draw the graph accurately as possible, especially if the point barely doesn't lie on the line and you don't visually see that. So it's always a good idea to make sure that you also prove it algebraically. All right, so now the next one is going to be the same thing, but we have y is equal to 5x minus 2. So now the easy way to solve this is just recognizing that since and then I probably should have mentioned this earlier, that when you have y is equal to mx plus b, m is going to be our gradient, and then b is going to be our y-intercept, right? Since our b here is -2, that means that our y-intercept is going to be 0, comma, -2. And so since our y-intercept is this point, then therefore this point will definitely be on our line. Otherwise, if you guys didn't remember how to identify your y-intercept, you guys can go ahead and just plug in as we did in the other two examples, and it'll still give you the same answer. So therefore, you'll say yes, the point 0, -2 does lie on the line. And there you go. Before we go any further, something that I do want to remind us is that when it comes to our x and y intercepts, so let me go ahead and erase all of this stuff, guys, because I want to make sure that we're all in the same page. Because I know that it's been a while since you guys had your algebra classes. So when it comes to your y-intercept, whenever you're trying to look for it, or just write it in general, the first step is always going to be to set x equal to 0. And then the second step is to solve for y. So then what you're really going to look at is 0, comma, our y-intercept, which we'll go ahead and call it a. So our y-intercept in general is when you set x equal to 0, you solve for y, and you'll have a point where a y-intercept at 0, comma a being any value for your y-intercept. For your x-intercept, your variables are just going to be flipped. So it's the same concept, just variables are flipped. So step 1, of course, is going to be now set y equal to 0. Set y equal to 0. And then step 2 is solve for x. So then in general, you have b, comma, 0, right? Because remember that our Cartesian coordinates is x, comma, y. So just remember that. And so that's how you guys in general find your x and your y intercepts for lines. Now before I move on any further, I do want to tell you guys about the show your work feature, where you guys can go ahead and just click on show your work. Hopefully it does it. There you go. So you're going to click on show your work, and then on here there's going to be a scribble feature that you guys can use. I have a pen, so it makes it easier for me to write. I know not all of us have tablets or pens to work with, so there's also a feature for you guys where you guys can use the text here. And you guys can go ahead and type in y, let's see, it's equal to, it's a little harder on the tablet. It's equal to mx plus b, let's see, plus b. And so, oh, I did not type x, mx. It's because it's trying to correct it. It's fine. And then plus b. And so you guys can go ahead and type that out and show your work. And so starting this semester, and not starting this assignment in particular, but starting the next assignment and going on forward, I'm not going to give you full credit if you don't show your work. And the reason for that is because functions is easy to mess up if you're not, first of all, working it out. And then second of all, if you are having trouble, it's going to be hard for me to see where we're stuck at if you're not showing any work. So more than anything, is just to help both of us to see where we're at and where you need help at. All right, so let's go ahead and power through the last two examples, and then that's going to be the end of this video. So let's go ahead and go through. So we have a line has a gradient of m is equal to 1/2 and passes through the point A, 4 and 8. Find the equation of the line in the form as y equal mx plus c. So notice that they have plus c here. It's the same thing as plus b. So just know that we can use any variable for the y-intercept. It can be plus f, plus z, plus whatever. But just know that, be familiar with the general formula that it's y is equal to mx plus b or plus c. And you should be fine. Now let's go ahead and we know what our gradient is, right? We know our gradient is y is equal to 1/2, right? So all you have to do is go ahead and plug it in. So we have y is equal to, and let's switch back to the pen, guys. Switching back to the pen. There you go. So y is equal to, and then our m is going to be 1/2. So let's go ahead and write 1/2. So 1/2 x plus c. Now, for us to be able to figure out what c is, and I'll go ahead and highlight c in yellow. For us to figure out what c is, I'm going to need a point, and lucky for us, we are given that point. And so our point is 4 and 8, right? So we're going to replace our x and y with 4 and 8. So remember that 4 is going to be our x, and 8 is going to be our y. So 8, so now we're going to have 8 is equal to 1/2, and then our x is 4. So let's go ahead and replace x with 4. So 4, and then plus c. So we know that 1/2 plus 4. So let's go ahead and leave the left side alone. So 8 is equal to b, and then 1/2 times 4, that's going to be 2, right? So 1/2 times 4 is 2. And then we're going to have plus c. Now this part, for some reason you guys were struggling with, we're trying to get c by itself, right? And we see 2 and c, they're both adding, right? So that means that we're going to stick into the realm of adding and subtracting. So now I have to figure out, since I'm trying to get c by itself, I have to figure out whether I'm going to add or subtract 2 on both sides. Since 2 is positive, what I'm actually going to do is I'm going to go ahead and subtract 2 on both sides, because that's what I'm trying to move. So 2 minus 2, that's going to cancel out. And then 8 minus 2 is 6. So 6 is equal to be c. Okay? Now I know what my y-intercept is. So my answer is going to be y is equal to 1/2 x plus 6. And so this is the equation of the line with gradient m equals 1/2 and passes through the point 4 and 8. Now for the final example, we have a line passes through the points -2 and -5 and 1 and 13. Find the equation of the line in the form of y is equal to mx plus c. So now with this one, we're only given 2 points, right? And so what that means is that we're going to go ahead and have to use the formula m is equal to y2 minus y1 all over x2 minus x1. So that's what that means. Whenever you're given 2 points and you need to write an equation of a line, that's the formula that you're going to go to. Now, this part here, I'm going to go ahead and label my points. So I'm going to go ahead and assign point A as my first point. So that's going to be x1 and y1. And I'm going to go ahead and assign my point B as my second point. So it's going to be x2 and y2. Now I'm going to follow the formula. So m is equal to, so when I follow the formula, I see that y2 is going to be 13. So 13 minus, and then my y1 is negative 5. So 13 minus negative 5 all over. And then my x2 is going to be 1. So 1 minus, and then my x1 is negative 2. So minus negative 2. When I work it out, let's see what we get. So we get 13 minus negative 5. So minus negative basically means plus, right? So we'll get 13 plus 5 over, and again 1, and then minus negative is plus. So 1 plus 2. So 13 plus 5 is going to be 18 over, and then 1 plus 2 is 3. And then how many times does 3 go into 18? So hopefully you guys said that that's going to be equal to be 6. There you go. So that means that my slope is 6. And so we're going to repeat the process we did from example number 7, where we have y is equal to, so now I know that my m is 6, so 6x plus c. And now all I need to do is figure out what c is. You can use any point. It doesn't matter whether you use point A or point B. You are going to arrive to the same answer. And so I'm just going to use point A just because. Okay, so let me go ahead and plug in what I need to plug in. So then let's see. So we have, and let me go back actually. So because I am using point A, my x value is going to be negative 2, and then my y value is going to be negative 5, right? So my output is negative 5. So that means that negative 5 is equal to 6 times, and then my input is going to be negative 2. So let's go ahead and plug in negative 2. And then plus c. And then again, the whole process is the same. So negative 5 is equal to b. And then I know that 6 times negative 2, positive times negative is equal to a negative. And then 6 times 2 is going to be 12 plus c. Now again, remember that negative 12 and c are both adding, so I'm sticking to the plus and minus realm of our order of operations. So now I have to look at negative 12 because that's what I'm trying to move over to the other side. Because it is negative, I'm going to go ahead and add 12 on both sides. So then this will cancel out, and then 5 plus 12, or negative 5 plus 12. What does that give me, guys? So it should give us 7. So C is going to equal to be 7, right? So our final step, of course, is going to be for us to write our final answer. So y is equal to be 6x plus 7. So that's going to be our formula, or our equation of the line that has the points, or that goes through the points negative 2, negative 5, and 1 and 13. And so now, let me go ahead and clean the board real quick, and then I'll be right back. Okay, so hopefully I can move it around. So for an assignment, guys, for today, your homework is going to be to go ahead and finish the rest of this goal formative assignment. Your practice is going to be questions number 9, 10, 11, and 12. And so these questions are a little bit more involved compared to the example. So if you guys have any questions, I will be posting my office hours. Office hours sounds weird. I'm in my tutoring hours in Schoology, so you guys can go ahead and check that out. And good luck to you guys.